Hello everyone. I'm going to start looking at brute force questions, and I think we'll start with an easy one. I'm going to use a question from CodingBat today, not Caddis, because I want to give an introduction to recursive backtracking, and I didn't think there was anything simple enough in Caddis, or at least I couldn't find one. On the other hand, on CodingBat, there is a whole category on recursive backtracking, which is this recursion to category here. So if you already understand the basics of recursive backtracking, then just give this category a go. It'll probably only take you a few minutes to do each question there. There's like 8 or 9 questions there. And in case you never heard about CodingBat before, I think it's a great resource for learning Java, especially if you're just starting out, because there's just heaps and heaps of problems for you to do. And they're mostly easy. So if you're already good with Java, you're probably not going to get much out of them. But if you're new to the language, then it's a nice way to get used to Java because it forces you to write a lot of code. They also have a Python section actually, and I used this when I was first learning Python. So we're actually going to do a question in the hardest category, that is the recursion to category. So let's go there, and just going to do the first one here. GroupSum. The question is actually very simple. You're given an array of integers and an integer, and then you're asked to check whether or not it is possible to choose integers in the array such that they add up to the integer that you're given. For example, if you're given the array 2, 4, 8 and the integer 10, can you make 10? Well, sure, because 2 and 8 will add up to 10. Can you make a 9? No, because, well, 2, 4, 8 are all even numbers, so there's no way you can make a 9, which is odd. So if you can make the sum, return true, otherwise return false. That's all you got to do. And I'm going to use the approach that I talked about in the previous video. That is where I discuss how to break down problems into small subproblems. If you recall, I represent problems and subproblems as nodes in a tree. So going down the tree means I break down the problems into smaller and smaller subproblems. So hopefully you've seen that one, and what I'll say here will make sense. Okay, let's see how we can break down our problem into small subproblems. Let's start from the top. At the start, we have the whole array and we have a target. So this node here represents our main problem where we have to make 10 out of the integers in this array. Actually, let's just put 10 in the node. So this node represents our target. Now, to do these kind of questions, you probably have to try every single combination. So that's what we're going to do here. And if I want to try a combination, I gotta start somewhere, right? So I can pick 2, I can pick 4, or I can pick 8. Actually, I can also pick nothing if I want to. So there are 4 ways we can reduce the problem. And this is what you need to be able to do. You must be able to recognize the different subproblems from whatever decision you make. For example, if you pick 2, then your target is now 8, but you have a small array where you can choose numbers from. So this node here is the same problem, but with a different input. So is this node here, and so is this node here, right? Because if you pick 2, you get 8 left. You pick 4, you have 6 left. You pick 8, you got 2 left. But these are all the same problems. Now, what happens if you pick 0? Well, you're gonna end up with 10 as a target and 2, 4, 8 as the array again. So that is exactly the same problem as this one. So there's really no point doing that branch of the decision. Like there's no point going down this way. So we're just gonna ignore that. Now, what do you do if you want to solve these subproblems? Well, if they are the same problem as the original problem, then you should solve them using the same exact function that you used to solve the original problem. In other words, you have to use recursion. So you're gonna call the function from the top, and then it has to work out all these small subproblems, and then it's going to call itself using these small inputs. So if you're at this node here, the one with 8, you're going to apply the same principle, namely, for each option you have, you're going to have a new subproblem because you got to try that combination. So how many options do we have here? Well, there are 2 options. You can either pick a 4 or you can pick an 8. If you pick a 4, you're going to end up with target equal to 4. Which you can't actually make because you got 8 left. If you pick 8, then you have 0. You're happy because you got the sum. 0 means you don't have to pick any more numbers. So again, this branch is dead because there's no way you can make 4 out of the remaining element in the array. And this branch will give you the answer. So you're at the very top, you use recursion, you go down each branch, and you go to this node, you go to this node, and that's a dead end. So here you should return false, and then you go back up here, and then you go down to this node here, and this node got a 0, meaning that you found the answer, and then this should return true at the top. So now this branch has to work out what to send back to the original function call, to the boss. So he checked out these 2 possibilities. This one returns a true, this one returns a false. And well, if there's a true being returned, that means there's a correct answer somewhere. So this node will return true to the top. And at the very top, when it finishes checking all the branches, there is at least one true, then there's an answer. With this example, maybe we can stop here because we found an answer, but in general, not all the branches will give you an answer. Well, you can see that already because if you go down this path, then you're not going to get an answer. But let's say we start from the top and we go down this path, taking 4 at the beginning. We're actually stuck now because we have 2 or 8 to choose from. We can't pick an 8 because if you pick an 8, you're going to end up with 12. So we can ignore this branch. And if I pick 2, I'm going to end up with a total of 6, so I still have to make 4. And well, that's not going to happen because the only thing we have left is 8. So we got lucky that we found an answer so quickly by going down this branch. But potentially we may have to evaluate every single node or every single branch before you find an answer. Actually, if there's no answer, then that is exactly what we have to do, as in we know there's no answer. Why? Because we checked every single node in the tree. There's one more thing I want to note, and that is if we pick 8 at the start, we will then have the option of picking 2 or 4. And of course, picking 2 will give you the answer, and picking 4 will get you nowhere. But this is exactly the same with what we did earlier in this branch here. Because picking 2 and then picking 8 is the same as picking 8 and then picking 2. And this is actually a very important point. In terms of breaking down problems into subproblems, is this approach correct? Yes, it is, and it does work. I mean, it does break down the problem into small subproblems and eventually does give you a solution. But we're doing too much work here because the order that we choose the elements doesn't matter. As in, it doesn't matter if you choose 2 first or 8 first. All that matters is that you choose both of them. So personally to me, this is a natural way of breaking down the problem into subproblems. But this is actually not an efficient way to do it. Why? Because here we care about the order, we care about the different permutations. Whereas all we need to care about is just the combinations. Again, it doesn't matter if I pick 2 first or I pick 8 first. It should not matter. However, with the way I break down the problems here, it does matter. So how can we make it more efficient? Well, if you're faced with this kind of problems where you only care about the combination, then there is a different way that you should break down the problem, and I'm going to go through that now. So we're going to start over from the top. And this is where we have to change our thinking a bit. Originally at the start, I was thinking, oh, I can choose 2, I can choose 4, or I can choose 8. Because to me, that's more natural. That's what I do in real life. I have a problem, then I can look at all my options. Which one should I do first? But now, I'm going to do something different. I'm just going to focus on the first element, and that is the element 2, because I can either use it or not use it. And this will lead to 2 different subproblems. If I choose 2 to be part of the sum, then I only have to make 8. But I can also choose not to use it, meaning that I'll still have to make 10. In both cases, I will have 2 numbers left in the array, 4 and 8. So again, these are 2 different subproblems, but the problem is slightly different because you don't have to choose a number from the whole array. You just have to consider whether or not you want the first element of the array. See, the array still gets smaller and smaller and smaller. The number will also hopefully get smaller and smaller. but it's not the same as before. Before you have to consider all the elements in the array. Now you only look at the first element. So with this branch here, you have two options. Either you take 4 or you don't take 4. If you take 4, then you still have to find another 4, which you can't do because there's only 8 left in the array. If you don't take 4, you still have to make up 8, which is great because we only have 8 left in the array. But anyway, let's go down this branch first. If I do take 8, I'm going to end up with -4. So that's not the answer. If I don't take 8, I'm going to end up with 4 here. So again, that's not the answer because we want to have 0 here, right? And if I go down this path, I'm going to have 0 if I take 8, and that'll give me the answer. I hope you can see that now we don't care about the order because we go through every single element in the array one by one. This is a very common pattern that we use when we want to enumerate every single combination, and you really need to get this technique under your belt because it is the correct way to break down a problem where you have to find every combination. If you need every permutation, then use the previous approach. If you need every combination, use this one because it's more efficient. Why is this more efficient? Well, let's think about how many subproblems you have to evaluate in total. If you know permutation and combinations, you should already know the answer to that one, but let's just go quickly through it. Starting from the top with the second method, we have two options, right? Either pick the first element or don't pick the first element. So there are two subproblems, and each of those subproblems going to make 2 more subproblems when we pick the second element, and then 2 more when we make the third element. So there'll be 8 subproblems in total at the bottom. So that's how many subproblems we have. What about the first method? Well, on the first level, there are 3 options that we can choose from. On the second level, and I didn't draw all the nodes here, but there are always 2 elements left in the array on the second level. And then on the third level, there's 1 element left. Oh, don't forget that there's actually one more move here that we need to make. So it's going to look like 1 from the top, 3 options. And for each one of those 3 options, we have 2 more options. And then for each one of those, we have 1 option. So that's the total number of subproblems we have to evaluate. That is 15 on this side and 16 on that side. Well, doesn't seem like a big difference. But what if we now have 4 elements in the array? Well, with the second method, this tree here, each one of these subproblems at the bottom are going to spawn 2 more subproblems for the 4th element in the array. So that's the number of subproblems that we have to evaluate now. We add 16 more. And I hope you can see that the number of subproblems you have to evaluate is just 2 to the power of n, or 2 to the power of n minus 1 to be exact. I mean, every level is always a power of 2, right? 1, 2, 4, 8, 16. What about the first method? Well, now on the first level, you have 4 options. Now on the next level, you have 3. On the next level, you have 2. On the next level, and remember there's still 1 more, you have 1 option. And it's pretty obvious. You have a lot more nodes to evaluate here. I can't even draw them properly because this is permutations. This is n factorial. This is 2 to the power of n. This is combinations. So of course you're going to have to evaluate a lot more combinations, well, permutations, if you do it using the first method, because again, you are evaluating permutations, not just combinations. Hopefully that convinced you that the second method is better because that's the approach that we're going to use. So I'm going to put up this tree here for reference, and we'll start writing the code. Now, I mentioned in the previous video that I like recursion better because it's simpler. Can you do this question using a loop? Yes, you can. It's just a lot more annoying. I like recursion because when I write this code, I can just concentrate on one subproblem. Like I imagine myself that I'm here somewhere. I get some input and I just have to do something with that input to produce the output. So let's start doing this. Let's imagine that we're at the top. Although I guess I like to move around a bit when I code, as in right now I'm imagining myself up here and thinking what input do I have at the start. Then I jump down and imagine I'm at this node here at the bottom. Then I gotta think, how do I stop the recursion? When does it stop? Then maybe I'll move up here and I use something concrete, like the array is 4 and 8. That means I have to start looking from the second element of the original array. So how do I do that? What do I send back to the top? And then I go up here again. I'm thinking, well, I'm going to get something back from my function calls. How do I process the return values? So you got to make a function that works everywhere. So you got to think about all the possibilities and how each function call communicate with each other. And actually, important part of that is the input parameters. So probably you should talk about these first. Nums is obviously the array of integers that you're given, so you always have to pass that around. Target is the target sum that you have to make, so that's also obvious. Start is the index of the subarray, as in your array gets smaller and smaller and smaller, but you don't modify the array, right? You're not making a new array, you're just passing the same array. It's just that the starting point gets later and later and later. So when you start off, start is going to equal to 0, and then the next time you call it becomes 1 because you're looking at the second element, and then becomes 2, becomes 3, and so on. So now that I think about it, that's actually a very good starting point because we know when we have to finish, or at least one of the reasons why we finish. That is if we run out of numbers. So if at any point we don't have any more numbers, we have to say false, as in I can't make the target. So if nums.length is less than or equal to start, well, actually, maybe it's better to write this the other way around. If start is greater than or equal to nums.length, then, well, do we have the target or not? If we already have the target, if we get to the end of the array, but we actually found the target, as in the last element of the array makes sum, then we have to return true. So now I'm thinking, well, I'm going to return false here for sure. But before I can do that, I have to check to make sure the target is not equal to 0. Because if the target is 0, that means we found a combination of integers that add up to that number. So to add up to target, sorry, so we have to return true here. I hope that makes sense. Let me say it one more time. So I know I'm going to have to stop when I run out of numbers. So that's this condition here. But what can happen is that the last number that I check, so from the previous function call, I worked out that the last value of the array makes the target. So for example, the last value is 8, and I have to make it 10. So or the value so far is 2, so 2 plus 8 becomes 10. So when I grab that 8, I'm going to call the function again. This time target becomes 0, as in we're down here, basically, with this node. When that happens, I have to return true. If that is not the case, and I have run out of numbers, then I will return false. And now that I think about it, this return true can happen earlier, right? Because at any time your target becomes 0, you're done. Can you also return earlier with the second condition? As in, do you always have to go to the bottom? Do you always have to check until you get to the last element of the array? Well, no, right? Can you think why? Well, let's say you gotta make 10, and the first number you see is 12. We obviously not gonna pick that number, but with the way this is done, with the way the code works, that you will pick 12 anyway, and then your target becomes -2 because you do 10. Well, I got 12 here. I'm going to do 10 minus 12. I get -2. So I have to make -2 more. But you know that there are no negative numbers in the array, so there's no way I can make -2. So how do we capture that? Well, minus 2. So if somehow target is less than equal to, sorry, not less than equal to, just less than 0, you return false. So these are the stopping conditions that I can think of right now. Can't think of anything else right now. Maybe that's all we need to do. So now I guess we'll have to write the recursive call. So when I first start off, start is equal to 0 because I'll be asked to look at the first element of the array. So you got two options. Either you pick the number or you don't pick the number. For each one of these options, you gotta make the recursive call. So here I'm gonna do GroupSum. This is gonna be start plus 1 for sure because you're gonna be looking at the next element in the array. Then you're gonna be passing a nums because that's just the array. Now this is the first function call, and what do we pass here? Well, you're gonna do it twice, so it's gonna be the same. This one is when I choose the number, as in I include in the sum. So if I include the number, the target should now become smaller because see here, the target is 10. I choose to use 2. Now target becomes 8. So I'm just gonna have target minus nums start. Here, I do not choose the element. So I'm just gonna send target. Is that it? Well, no, because I still have to return an answer. I'm not returning anything here, like down there. So now I imagine I'm at the top here, and this first one is going to the left, GroupSum going to the left, and GroupSum going to the right. So I know that these guys, the two function calls, they're going to return either true or false. True means that target becomes 0 eventually somewhere. I don't know where, but in one of the nodes below me, it becomes, it is the case that target is equal to 0, then it will return true. So they can both return false, they can both return true, or it can be the case that one of them return true, the other one return false. So all I care about is that I get a true somewhere. There's an answer in one of the nodes. So how do I grab that? How do I make sure I return true if there's a true somewhere in the whole tree? Well, what is true or false? It's going to be true. So here return the result from the left node or the result from the right node. If one of them is true, you're going to return true. And that is what we're going to return. And I think that's it. That's all you have to do. So let's give it a go. Yes, that actually does it. So this is a function that will work on every node, at the top, at the bottom, anywhere. And in this video, I constructed this very slowly. I don't know, some of you probably find this to be boring, and if that's the case, good. You can start doing these exercises and see how you go. But I'm showing you my train of thought when I do recursive backtracking. So this is what it's called, by the way, recursive, because, well, you are using recursion. And backtracking because if you go down a branch and you can't find an answer, you have to backtrack, as in you go back to the top and then you go to another path. And I hope you can connect this with the video on problems and subproblems, because we're going to use this model again. I won't go into as much detail, as in I'll probably just throw one level. But this is the model that I'm going to be using when I explain how to solve different kind of problems. So hopefully you learn how to break down problems, and this is important because this is what we do when we need to enumerate every combination. So please practice with these questions, and I'm sure we'll see more of these questions later on, this type of questions later on. Anyway, I hope this video is of some use to you, and that's it for me. So thank you for watching.